Okay, so this one is the question number 7, and question is determine the time period of the system of mass m attached with a spring of mass ms and the spring constant is k. Okay, so you all are facing problem just because here mass of spring is given. We already solved too many questions based on the spring mass system, but yes, one thing was common on all the question was spring was massless, and here mass of spring is given, and that one is the ms, and the mass of block is given m. One thing, student, look at this. Here mass attached with the spring is very big as compared to mass of the spring. It means this spring is going to expand uniformly. Okay. The first thing what we are doing, we are calculating the mass per unit length of the spring, and that one is, if we are assuming the length of the spring is L, so mass per unit length of the spring is ms upon L. Okay. Now we are going to consider an element. Look at this. Generally I used to take an element as dx, but I'm going to expand this spring by x. So that's why I'm choosing another variable like ds. From here, s distance part, I'm considering an element of ds. What is the mass of this element? So the mass of this element is, I'm writing at dms, and that one is the lambda into ds. Lambda is what? It's a ms upon L into ds. This one is the mass of the element. Now, student, look at this. If we are expanding this spring by x, okay, if this spring is expanded by x, then how much this ds will displace? So first I am writing here the displacement of element. Okay. Displacement of element, and that one is what? That one is x upon L into s. Okay. Now look at this. If I am calculating the instantaneous velocity of element, instantaneous velocity of element, what we can write? So this one is the s upon L, dx upon dt. Okay. Now if I am asking her what is the kinetic energy, instantaneous kinetic energy. Instantaneous kinetic energy of element. So look at this. Mass of the element is given. So 1 by 2 mass of the element, which is the ms upon L into ds. This is the mass of ds. This is the mass of element. Now what is the velocity? Velocity is this one, the square of this. So it's s square upon L square dx upon dt L square. Okay. So this one is the kinetic energy of element. Now if we want to calculate the kinetic energy of whole spring, how we will calculate? So the kinetic energy of spring, how we will calculate? So simply we will integrate it from 0 to L. Okay, so that we are going to do. So here what are the constant? 1 by 2 ms upon, this will be L cube. Now here we have a s square dx by dt whole square. So I am writing s square here ds, and the s is varying from 0 to L. So that's why I am putting a limit. It is from 0 to L. Now if you will integrate, what you will get? 1 by 2 ms upon L cube dx upon dt whole square, and this will be L cube upon 3. This L cube will cancel out, and we will get 1 by 2 ms upon 3 dx upon dt whole square. So this is the kinetic energy of spring. Now if we want to calculate the kinetic energy of whole system, the kinetic energy of system, the kinetic energy of system will be what? The kinetic energy of spring plus kinetic energy of this m block mass. So what we can write? 1 by 2 kinetic energy of spring is ms upon 3 dx upon dt whole square plus kinetic energy of that mass is 1 by 2 mass of the block into velocity. That one is the dx by dt whole square. So what we can write? This is the kinetic energy of system. What we are getting? 1 by 2 mass, so ms upon 3 plus m into dx by dt whole square. It means for this whole system, the spring plus mass, the effective mass is what? This one. This is the mass effective, which is the m plus ms by 3. Now, yesterday we already used the formula for the spring mass system. The time period is what? So time period is 2 pi root under m effective upon k, and we already got the mass effective. It means what? We can calculate the time period, and the time period will be 2 pi m plus ms upon 3 divided by the spring constant, but the spring constant is given here k in question. Okay, so look at this. If we have a question and the mass of a spring is given, then how you will solve? Like this. Understand? Okay, come to the next question.